Before class assignment number 14, threads and fasteners. The following fasteners can be found in a Ziploc bag in the top drawer of the file cabinet just outside my office in the machine shop, Austin 171. Determine the correct specification for each fastener. Use only digital calipers. Do not use the thread pitch gauges or any other object with a known thread. Once you've determined the thread specification, write that specification according to standard. Also determine the length of each, where applicable, and the size and type of wrench that would be required for each. The 10 points for this assignment will be obtained 3 points for this first fastener, 3 points for this second fastener, 3 points for this one, external thread, internal thread, and the wrench size, and a half a point for each of these, the thread spec and the wrench size, for 1 point on that nut. So let's talk a little bit about fasteners. First of all, what's the difference between a bolt and a screw? Well, there's some pictures, and we find that a bolt is designed to be used with a nut, and a screw doesn't need a nut. For instance, machine screw or cap screws are designed to be threaded into a tapped hole. A bolt could certainly be threaded into a tapped hole, but maybe it doesn't have quite the tight tolerance on the thread that a machine screw would. A lot of people are used to these self-tapping screws. If you think of wood screws or sheet metal screws, a lot of people think that's the only type of screw. But most screws are actually look just like a bolt. And you'd only know if it was a screw versus a bolt if you could somehow figure out the tolerance on the thread. I could certainly use a machine screw with a nut, for instance. Or I could certainly use a bolt to screw into a tapped hole. I could use a bolt as a screw, or I could use a screw as a bolt. Let's take a look at some of these. Which are screws and which are bolts? This one for sure is a bolt. There's no other way to tighten it from the head, so it has to have a nut. So that one's certainly a bolt. This one's probably a machine screw. Could we use a nut with that? Certainly we sure could, but it probably has tight enough tolerance that it would categorize as a machine screw. This is certainly a screw, would be considered a socket head cap screw. This is a flathead machine screw. This is a set screw. And this is either a bolt or a screw, depending. It's probably a bolt, but you could certainly consider it to be a hex head cap screw. Maybe the only indicator is those grade markings on the head that indicate that it's a bolt. A hex cap screw would look almost identical. Might just have a slightly closer tolerance on the threads. Let's take a look at nomenclature for threads. We talk a lot about nominal diameter, major diameter, pitch diameter, tap drill size, minor diameter, and pitch. We also talk about TPI and how that's related to thread pitch. So let's see if we could figure out what these names mean. First of all, if I see an English thread that's a 3/4 10 UNC, the 3/4 is the nominal diameter. There's really nothing on that thread that will measure the 3/4 of an inch. The nominal diameter is a little bit bigger than the major diameter. If I were to measure the outside diameter of this thread, I would be measuring the major diameter. Nominal diameter is slightly bigger. This 10 is the threads per inch, if it's an English specification, and that is how many threads are there in 1 inch. A metric thread is a little bit different. The first number is, again, a nominal size, 14 millimeters in this case. But this second number, instead of threads per inch or threads per millimeter, it's just the inverse of that. This would be how many millimeters per thread rather than threads per millimeter. So a metric thread usually calls out the pitch, while English threads usually call out the threads per inch, which is the inverse of pitch. On an internal thread, there's one tap drill size that is very important to understand. If I were to cut this thread into a piece of metal, I'd first need to drill a hole, and the size hole that I need to drill would be the tap drill size, and then I would use a tap to cut the thread. So the tap drill size is usually the smallest diameter inside that internal thread. I've posted on iLearn this chart. This chart combines nominal diameter and tap drill sizes for 3 different thread types. The unified national threads, which is the most common English threads, coarse and fine. It also combines the coarse and fine metric threads that are relatively common, and it also shows the national pipe threads, NPT. This will be used as you determine the threads of those 4 fasteners that are located outside my office in that filing cabinet. So make sure you have this chart as you go to take measurements. If you're designing anything in the English system, you're probably going to shoot for some even increment of a 1/16 of an inch. And most designers will have those decimals memorized. It's also important to know the typical metric sizes. So let's take a look at how we might determine the thread specification. Here's a bolt, and we're measuring 0.740. If we look at the chart, we see that it's probably a 3/4 inch bolt, which would be 0.75. And of course, 0.75 is the nominal diameter, which should be a little bit bigger than our measurement. But we ask, is it a 3/4 10 UNC or 16 UNF? This one's pretty clear that it is a coarse thread, but if it wasn't clear, we could certainly measure an inch length and count 10 threads in that 1 inch. So we'd know it must be a 3/4 10 UNC. What if we didn't have an inch worth of threads? Well, I could measure a 1/2 inch worth of threads. And threads per inch just means I take the number of threads and divide by the number of inches. So if I count 8 threads in a 1/2 inch, I take 8 divided by 0.5, which would give me 16 threads per inch. So this set screw is probably a 3/4 16 UNF set screw. A lot of shops will have thread pitch gauges that you can hold up and see if it matches. Now for the assignment today, I don't want you to use the thread pitch gauges. I just want you to use a set of calipers. And what's special about pipe threads? Well, I've drawn this to an extreme, but a pipe thread is tapered. And this tapered pipe thread, it enables sealing. The tighter it gets, the more it gets wedged into the fitting. And quite often you'll use either pipe dope or some Teflon tape to facilitate the root of the thread's sealing. But not always. You could buy a dry seal pipe thread, which the metal would actually interfere at the root of the thread, and you wouldn't need the Teflon tape. When I say 1/2 inch pipe, a lot of people think, oh, it's the ID that measures 1/2 inch. That's not true. 1/2 inch pipe, there's really nothing that measures 1/2 inch on a 1/2 inch pipe, and that's true for most other pipe sizes. And that's because of the evolution that's occurred in the pipe sizing and naming scheme. This 1/2 inch pipe, for instance, is 0.840 on the outside diameter and 0.622 on the inside diameter. Neither one is 1/2 inch. So typically, if you want to know the inside and outside diameter of any pipe, you just have to go and look up the nominal pipe size on the table and see what the outside and inside diameters are. This is a pipe thread, and typically, because pipe threads are tapered, when we measure them, we better measure at the top of the thread, which is most closely related to the pipe size. When I'm measuring internal threads, for instance, in this case I'm measuring 0.657, and if you go to the chart, you'll notice that there's a tap drill size that requires a 0.657 tap hole to be drilled before the tap. So in this case, this would be a 3/4 10 UNC because it requires a tap drill of 0.656. So just with that measurement alone, we could figure out that this was a 3/4 10 UNC. So let's do another practice. You could say, what is the thread specification for this fastener? First of all, we see that this is a 0.432, which is a little bit smaller than 7/16. And we're counting 14 threads in 1 inch. So we would know that this is a 7/16 14 UNC fastener. Let's take this nut, for instance. This first measurement, 0.451, is pretty close to 0.453. And if we look at the chart, that looks like it's the tap drill size for a 1/2 inch fine thread. But let's just double check that it is a fine thread. So we'll measure the thickness of 0.433, and we count 9 threads in that thickness of 0.433. So if I take 9 threads in 0.433 inches, that's pretty close to 20 threads per inch. So that confirms that this is a half 20 UNF nut. How about this one? And I apologize that the photograph's a little blurry, but we're measuring 0.542 on the outside diameter. That leads us to think that, well, it could either be a 1/4 inch pipe, which is 0.540, or a 14 millimeter, which is 0.551. Well, let's count threads and see if it confirms which one we're dealing with. I'm counting 7 threads in 0.387 inches. So if I take 7 over 0.387, I get 18 threads per inch. If I were to do 0.387 inches per 7 threads, that gives me a pitch of 0.055, which is converted to a 1.4 millimeter pitch. So if I look at a 1/4 inch pipe, is a 1/4 inch 18, that's pretty close to what I've measured. A typical 14 millimeter is by 1.5 pitch, and that's not very close. I measured 1.4 millimeter pitch. So that confirms to me that this is a 1/4 18 NPT thread. And of course it also is confirmed by the fact that that's a piece of pipe. Let's also talk about head types. There are a variety of fasteners with a variety of different head types. For instance, there's a hex head, which is pretty common. Everybody knows about those. There's a hex flange head. There's also the round head with a square neck, which is typical carriage bolt. There is hex socket heads, which require an Allen wrench. There are also pan heads, philister heads, oval heads, flat heads. A flat head is something that will go into a countersunk hole and sit flush and flat with the top surface of the metal. There's also button heads, round heads. There's also several drive types. There's the hex drive, or the hex socket, or the tamper-resistant hex socket, or Phillips or slotted, or a combination Phillips slotted, or even a tamper-resistant slotted. Torx is more like a spline. There's the tamper-resistant Torx, the tamper-resistant drilled spanner, or even a tamper-resistant tri-groove. So a lot of different drive types on fasteners as well. Very valuable to get to know each one of those. Let's also discuss what size wrench we might use. For instance, if I wanted to know the wrench size, would the wrench size be the same as the nominal size? Clearly not. The wrench goes around the flats of the fastener, so if I wanted to know a wrench size, I would measure the flat to flat distance on the fastener. The measurement there on the right is actually measuring from peak to peak rather than from flat to flat. That's certainly not the right measurement to take. So this one shows that it's probably a 5/8 wrench that I would need for this fastener. What about which Allen size wrench would be appropriate? Well, it's certainly not the nominal size of the fastener. It's not the outside diameter either, but it's the width across the flats of the hex that's inside that socket. So in this case, this is measuring 0.190, which is slightly bigger than 3/16, so I would be able to fit a 0.188 or 3/16 Allen wrench into that. Threads on engineering drawings are often specified this way: half 13 UNC by 2. That would mean it's a 1/2 inch nominal diameter, 13 threads per inch, unified course standard by 2 inches long. It's important to understand that the length of a fastener is the length under the head, not including the head. Metric specification would be something like this: M10 by 1.5 by 20 millimeters long. Again, that length is under the head. Here's how you show them. If it's an internal thread, you show the inner circle as a solid line and the outer circle as a dashed line. Very self-explanatory that you would see the inner circle if you held up the part, but you wouldn't see the outer circle representing the edge of the threads. On a external thread, however, if you were to look at the end, the outer circle would be solid and the inner circle is dashed, which is self-explanatory again. So now go ahead and figure out the thread specifications and fill in the blanks for each of these fasteners, and we'll see you in class.